Hey guys, it's me, Ian, and this is a refresher on the adding and subtracting processes. You're going to need to know all of the processes for the final exam for addition, subtraction, multiplication, and division. Multiplication, division, that'll come later. Right now is addition, subtraction. So, just a quick recap to show you before I start anything. These are all 6 processes for addition, and then all 7 processes for subtraction, like their names. Okay, addition we're going to start with is 345 plus 788 with base 10 blocks. You're just going to, first, for addition, you're going to draw both numbers. So it's 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So now we have both numbers. These are getting added, right? Remember, for the final, you're going to need anything related to base 10, like anything related to drawing. Most of the time, you're going to need multiple different colors. Base 10 blocks for addition, no exception. So I like to do red first. I usually do red, then blue, and then if I need it, I do green. So I'm going to do red first. And you're just going to start making groups of 10, like just adding them together. So we're going to start with the ones. We have 5 up top here, and then 8 here, but we have 5 on top of that 3. So what we're going to do is take this 5 and then take 5 from the 8. All right? Bang. Bang. No more. We're going to sneak it there. So these 10 is now this long. Okay. Now we can move on to a different color because you want to see if you can make any more groups of 10, which we can't. We have 3 units left over. They're going to stay left over. Next, we're going to look at our longs. We have 4 up top, and we have 9 at the bottom. So we can take these 4, compare it with the 6 of these. Bang. And then, so now these 10 longs, 4, 1, 2, 3, 4, 5, 6. 6 plus 4 is 10. These 10 longs are now this flat. I didn't like the way that square looked. Sorry. Then we continue. Are there any more longs we can make with 10? No, there's 3 left over. Moving on to the flats. We have 3 up top, and we have 8 at the bottom. So we can take these 8, and then these 2. Bang. Bang, no more. Because now they are this cube. That's a cube, trust me. Any more 10s? No. 1 flat's left over. And then there's not 10 cubes. We only have the 1 cube. So then that would mean you count it up. So cubes is 1,000. We have 1. Flats, we have 1. Longs, we have 3. Units, we have 3. Our answer is 1,133. Okay, next up is expanded form. You're going to write it kind of like the standard algorithm, but like in expanded form, of course. So you're going to write it as 300 plus 40 plus 5, and then 700 plus 80 plus 8. And they're getting added together. So it's still the same thing as saying 345 plus 788, except you're splitting it up. So then now you just add like normal, starting from the ones place. 8 plus 5 is 13. Put a 3. Carry the 10. Gotta remember that. Because remember, 13 is 10 plus 3. So instead of carrying a 1, you're carrying a 10 because it's in the tens place. So yeah, 5 plus 8 is 13. Leave the 3. Carry the 10. 80 plus 40 is 120. Plus 10 is 130. Leave the 30. Carry the 100. 700 plus 300 is 1,000. Plus 100 is 1,100. Leave the 100. Carry the 1,000. And then you just bring that 1,000 right down, actually. But you still want to carry it. It's good practice for this method to just show and keep everything like its own place value. And then you just add it up. 1,100 plus 30 plus 3 is 1,133. Next, we have partial sums, which is going to essentially be a mix of the standard algorithm and this expanded form. In a way, that's how I like to think about it. Because check this out. 345 plus 788. You write it like this. You write it like expanded form. But instead of doing 8 plus 5 is 13, carry the 1, you're going to do 8 plus 5 is 13. You're going to write 13. And then 8 plus 4, you got to think of it as 80 plus 40. So that's 120. And then 7 plus 3, you got to think of it as 700 plus 300. So that's 1,000. And then just add these together. 3 plus 0 plus 0 is 3. 2 plus 1 plus 0 is 3. 1 plus 0 is 1. And then that's 1. So your answer is 1,133. Then we have standard algorithm. So this one should hopefully be a breeze. 345, 788. Carry the 1. 8 plus 4 is 12 plus 1 is 13. Carry the 1. 7 plus 3 is 10 plus 1 is 11. 1,133. Then we have our open number line. So for that, we can just draw our number line here and here. Gonna grab out my notes. Also, I want to make sure that there's no differences in how I did it. This is what I get for doing it in one take. Oh, whoa, that's multiplying. That's my unit 1 divider. All right. Yeah, so you were going to start with this number. So the way addition open number line works is you write down the first number. So in our case, it is 345. We're going to put that here. And then this second number, 788, we're not writing it down, but we're like adding it. So 345, we're going to add 788. So we can write it here to keep track. But you also have to make sure you're adding it by place value. And like in a way that would make sense as you would like teach it to a child. You can't just like, boom, plus 788, 1,133, boom, you're done. No, can't do that. That defeats the whole purpose of this method, actually. But what we can do is add 700, which brings us to 1,045. Then, to make it a nice number that ends in 0, just right here, very quickly, plus 5. Keep track on our side there. Let me actually plus 5, so we have 1050. We have 83 left. It's 1050. We still have to add 83. So what we can do, we could add 80, but an easier way we can do it is we can just add 50. That brings us to 1,100. And now there's 33 left that we got to add. So we can get rid of that 30 rather easily, plus 30. And then our last plus 3 is 1,133. So the big takeaway for addition over number line, write down the first, so the two numbers, your two endpoints are going to be the first number and the sum. That second factor, like that second number in your addition problem, are these numbers combined. Because remember, all these combined, 700, 50 plus 30 is 80, 5 plus 3 is 8, 788. And then finally, for addition, we have compensation. So remember, compensation is the one that in order to avoid carrying, you would instead add or subtract from a number to make it like a friendly number. So in this example, like the 12 plus 29, you can like add 1 to 29 and then subtract 1 from 12 to get 11 and 30. Still gives you 41. Or subtract 2 from 12, add 2 to 29, gives you 10 and 31. Still give you 41. So that's the beauty with compensation. There's lots of different ways to do it. So let's take, for example, our problem. 345 plus 788. Easy method. Add 5 to 345. And remember, for addition, whatever you do to one, you have to do the opposite to the other. So like adding 5, you have to take that 5 away. So like it's essentially like moving that 5. Because if you add 5 to both, now there's just extra numbers there and you're just like doing a whole different addition problem. Like say if we added 5 to both sides, that's 350 plus 793. These are not the same. So that's why we have to make it like we're like moving. Oh, hello. It's like we're moving the 5. So if we're adding 5 to 345, we have to take it away from 788. So now we have 350 plus 783. The only issue with this one I have this. I have all this space, man. Hold on. I'm so sorry. Oh, hello. Got it. I got too into it. That's a 0. Okay. The only issue is 8 plus 5 is 13. You still have to carry. And then 7 plus 3 is 10, plus 1 is 11. Still get you 1,133, but you did have to carry in the tens. Now, another way is making 788 800. Because if you make it 788 to 790, right? Add 2 minus 2. You get 790. And you get 343. But we still run into the same problem. 9 plus 4 is 13. You still carry. This isn't like the greatest example for compensation, I would say, because you still end up carrying at some point. The whole goal of compensation is to avoid carrying or borrowing. One way you could do it, actually, is 345, 788. Add 12. I would say add 12 to 788 and then subtract 12. It still is frowned upon because, like, you want to kind of do it in, like, simple matters. So you want to, like, I believe that you should be only adding, like, by place value. So it'd really be, like, plus 2 minus 2 and then plus 10 minus 10 rather than plus 12. But also, I don't think it really matters. But this is also just not the greatest example, in my opinion. So, but if we do plus 12 minus 12, or I mean minus 12 plus 12, we're reading top to bottom, we're going to end up with 333 and then 800. And then this actually has no carrying at all. Because 3 plus 0 is 3, 3 plus 0 is 3, and then 8 plus 3 is 11. We don't have to carry because technically that's just the end of the problem. So remember, so see how they're the same exact answer, but we just added and did compensation differently? That's the beauty of compensation. And that is another thing you need. I believe it was on the Unit 2 exam. You're going to need it for the final, probably. Why do we use compensation? To avoid carrying or borrowing. Very important. Got to know that. And yeah, just a quick look. Here are the addition processes. That all equal the same answer, just different ways on how to do it. Subtraction is going to be a little different. We're going to do 923 minus 685. Starting again with our base 10 blocks. It's different for subtraction. Rather than drawing both numbers and then like adding them together, we're only going to draw the first number. So here's what that looks like. 1, 2, 3, 4, 5, 7, 8, 9, 23. So from this, we need to take 685 away. So again, different colors. And we're going to start with the ones place. So we have 3. We need to take away 5. We cannot take 5 away from 3. So what do? See this long here? That's the key. This one long is holding 10 units. So what we're going to do, we're going to steal them. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. We stole all of his units. Now we have 13 units. We can take 5 away from 13. Look at that. Or actually, I like to do the slash. I like to do the X for when we're like breaking it down, and then the slash for when it's like actually being taken away. So hold on. I almost forgot my own methods of drawing. Because I used to not, during Unit 2, I used to not draw it this way. And then now I do. There we go. There's our 5. And we're left with these units left. So that's 8 units. Next, we can move on to our longs. We have 1 long. Because remember, we took this one away. We took his units. This second one with the X, it's not a long anymore. So we really only have this one. So we have 1 long, and we need to take away 8. We cannot take 8 away from 1. So what are we going to do? We're going to take a flat. Bang, bang. We're going to steal its units, or we're going to steal its longs. Then check this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. We have 11 units. And now we can take away 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're left with these 3. Then we have 1, 2, 3, 4, 5, 6, 7, 8 flats. And we need to take away 6. We can take away 6 from 9. Check this out. 1, 2, 3, 4, 5, 6. Whoa. Look at that. See, this is why we start with the 1s. And then just like keep moving. Had to take away no flats. So then you just look at what you're left with. 2, 3, 8. 238. Wowza. Okay. Expanded form. It's going to look semi-similar. We're going to have 900 plus 20 plus 3. And then 600 plus 80 plus 5. But we're subtracting. The plus signs are still here because remember, it's like we're just expanding out the number, but like it's still the number. So like 900 plus 20 plus 3 is 923. The plus signs are there as like the connectors, like keeping it together. Like, I don't know, it's kind of like, I hope you guys get it. Like, it's kind of like a bridge, right? And like each bridge piece, in order to make it walkable, like there's the strings connecting the bridge pieces. The plus signs are like these strings. If you're picking up what I'm putting down, you know? Okay, all right. Expanded form. So, 3 minus 5. We have to look at it like this. 3 minus 5. Can we do 3 minus 5? No. So, what are we going to do? We're going to take a 10. Now we have 13 minus 5. That's 8. And we have 10 minus 80. Can't do 10 minus 80. So we're going to take 100. Now we have 110 minus 80. That's 30. And 800 minus 600 is 200. 200 plus 30 plus 8 equals 238. And then now look at that. Already at the traditional standard algorithm. 923, 685. I'm going to take here. And then that's that. And then 8. Take here. That's that. 3. And then 2. 238. Okay. Now we have the open number line. But there's 2 open number lines. There's takeaway and there's distance between. Depending on the number, depending on the problem, one is going to be better than the other. So, but for the purposes of this, I'm gonna show you both. So let me just throw that over there. Ooh, bang. Ooh. Okay, first I'm gonna do takeaway. So the way this is gonna work, on the right side, because how number lines work, over here is less and over here is greater numbers. And they progress like that. You can even draw like a music sign. You're gonna like progress like that and get like larger. See, that's the sign for louder. It's like it kind of makes sense in that context. And then it's the same is true for like the other way. This way, it's gonna get quieter. Or I started talking about music again. I got too into the bit. It's they'll get less on the left. They'll get smaller. There we go. That was the word I was looking for. Okay, so the way hold on. All right, the way takeaway is going to work is we're going to, on the right, start with our large number, which is 923. And I don't like the way I wrote that. 923. Then we're going to take away the second number. So 685, we're taking that away. So first jump, first big leap can be a little bigger, actually. Boom! Look at that. That is minus 600. So 923 minus 600 is going to leave us with 323. Then, remember, by place value only, you could just we could subtract 23 and then get to 300, but we actually can't do that. So I actually lied to you. So I kind of want to get to 300. Actually, no, I don't. I'm lying to you. Well, actually, you know what? We could. That's what we'll do. But first, we're going to take away our 20. So then we have 303. Then, hello. That's 300. Then, we can take away 40. Wait a minute. I did it wrong on my homework. What? I just added that up. I did 600. I did 665. What? How did I get 238 with that? That makes no sense. Huh? Okay, whatever. Um, it'd be minus 60, which would get us to the 240. And then minus 2 is 238. And then to double check, all your numbers, like all your homes, should total up to be 680, like your second number. So 600, 60 plus 20 is 80, 3 plus 2 is 5, 685. Okay. Wow. So yeah, that's takeaway. And then distance between. The way that's going to work, we're going to draw our number line, and we're actually going to put both numbers. So we're going to put 685. We're going to put 923. And we're going to get to the distance between them. So we're going to try to reach some friendly numbers. So starting with 685, what we can do is we can do plus 5. Actually, you don't even have to put the pluses here or the minuses. What we're going to do is we're just going to know the distance. So here we're going to get to, here we're going to get to 690. That's 5. Then 700, that's 10. On the 923 side, that's 3. So now we have 920. And then that's 20. So we have 900. And then, boom, that's 200. And now the numbers are connected. So then, little plus signs, bang, 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 bang. All these numbers in the middle of the two numbers, the distance between, see what I did there? The distance between is going to be your answer. So you just add them up. 200. 20 plus 10 is 30. 5 plus 3 is 8. 238. Next we have compensation. We have 923 minus 685. Remember why we do compensation. We want to avoid carrying, or big for subtraction, we want to avoid borrowing. Because sometimes, you see what happened here? Sometimes borrowing can get a little confusing with all the crossing out and carry, where are you taking the numbers from? What's the next number going to be? All the crossing out, it gets all messy. It's kind of disgusting looking. So, compensation, we can avoid that. So, the big things you want to look for in order to do compensation is either how do we get the top number to be larger than the small number. Peak would be a bunch of 9s or something versus any other number, because not in any digit 9 is the highest digit. So if you have 9s on top and then something less on the bottom, like 8s, you're chilling. No borrowing there. So you either want to do that or make the bottom number significantly less. Hoping your a main goal could be zeros. If there's zeros on the bottom and then something larger than 0 in the top number, there's no borrowing there. So, keeping that in mind, looking at our problem, 923, 685. What we can do, we have 923. If we subtract 23, that gets us to 900, but then that zero is on the top. That's especially what you don't want. Like if we do minus 23 and then, because remember for subtraction, you got to do both because you got to keep the distance the same. So 923 minus 685, and then we subtract 23 from both. We have 900, and then we have 662. See these? Borrowing. Oh! What? Out of here. Siri came on. What? Stop! Okay. So, can't do 23. Can't do minus 23 here. But you know what would be better than 23 in this sense? 24. Check this out. Minus 24 on both. You're left with 899. And then 661. 899. There's two nines. There's no borrowing. 9 minus 1, that's 8. 9 minus 6, that's 3. 8 minus 6, that's 2. Boom. No borrowing whatsoever. You could also, if you wanted to, and this is just like an afterthought, you could add to that bottom number. So we have like the 923, 685, right? We can do plus 15 to both. So that's going to give us 923 is now going to be 938, and 685 is now going to be 700. 8 minus 0 is 8. 3 minus 0 is 3. 9 minus 7 is 2. Also 238. So those are two different ways to do it. Making top number be larger than bottom number, preferably with like 9s, but as large as you can get it. Or making bottom number smaller than the top number with like 0s and whatnot, preferably 0s. So those are two examples for compensation. Still get you the same answer though. And remember, for subtract, again, biggest takeaway for compensation, cannot stress this enough. For addition, whatever you do to one number, do the opposite for the other number. Whenever you do subtraction, whatever you do for one number, do the same thing for the other number. Because you got to keep the distance the same between them. Cannot stress that enough. Anyway, Euro-Asian algorithm. So this is essentially the standard algorithm, with a twist. Ooh, all right. So 923, 685. But we're gonna put our line like here. Trust me on this. So 3 minus 5 can't do that. So we're gonna do 13 minus 5, but instead of crossing out, right, we're going to put it on the bottom. 13 minus 5 is 8. And then 2 minus 8, minus 1. The 2 minus 8 can't really do that. So rather than crossing out the 9 and making that an 8 and then giving this 12, this is still going to be 12. And we put our 1 down here. 12 minus 8 is 4, minus 1 is 3. 9 minus 6 is 3, minus 1 is 2. So that's essentially all you're doing. Rather than crossing out, you're just putting the one that you're borrowing on the bottom and then subtracting it later. Like instead of subtracting like 8 minus 6 to be 2, you'd be doing 9 minus 6 minus 1. Still getting the same answer. So you're still getting 2. See how I still got 2? Except you're just not like doing the 8 minus 6. It's 9 minus 6 minus 1. And yeah, just a quick look. These are all of the subtraction processes for 923 minus 685. And then just a quick look again. This was all the addition. And there you go. Thank you so much, and happy studying.